Let's use a classic example to explain the relativity of velocity. Suppose that you're on a harbor watching a ship coast by at 20 meters per second. On the ship, you see a man running. Now, relative to the ship, that is, in the man's reference frame, he's going 5 meters per second. So, relative to you, that is, in your reference frame, the man is going 25 meters per second, right? No. It had already been observed by Galileo in the 17th century that speeds don't simply add together like that, but it would take almost 300 years for Albert Einstein to explain to us, the bright young physics students of tomorrow, as to why. Now, let's start with what we thought we knew. We thought that the speed of the man relative to us would be u plus v, where u is the man's speed relative to the ship, and v is the ship's speed relative to us. It turns out that we need to use something called the relativistic equation of velocity to ascertain the true quote-unquote sum of the speeds. The equation, instead, looks like this. U plus v divided by 1 plus u times v divided by c squared. As you might imagine, c is the speed of light, which, in a vacuum, is 3 times 10 to the 8 meters per second, regardless of the speed of the observer. Nothing in the universe can move with a velocity greater than that of light in a vacuum. 1 plus uv divided by c squared, as you could probably tell, is pretty close to 1, since c squared is such a huge number. But this factor does count when the speeds u and v are close to light speed. So let's actually take a look at what the speed of the man on the boat relative to us in our reference frame sitting on the harbor would be using the relativistic equation of velocity. Well, the speed would be u plus v, which is 5 plus 20, so which is 25, divided by 1 plus 5 times 20, divided by 3 times 10 to the 8th all squared, which would be about 9 times 10 to the 16th. This is in terms of meters per second. Now, as you could probably see, 25 divided by 1 plus 5 times 20 divided by 9 times 10 to the 16th is pretty close to 25. In fact, it's 24.999 something. However, we begin to see, as we will see in future videos, that the relativistic equation of velocity produces a much different speed when both u and v are close to light speed. Thank you for joining me in this video. I hope that I've helped, and I will see you in the next one.